Yes, very good morning. In our last class, we discussed about some of the interesting points in isometric projection and how to construct a simple isometric projections like pentagon, hexagon, circle. These things we discussed in our last class. Today, we are directly move on to a problem number 1 in isometric projection. Okay. So, the first problem is a sphere of diameter 50 mm rests centrally on the top of the cube of the side 50 mm. Draw isometric projection of the combined solid. Here isometric means it's a combination of solids, like a one solid is placing over another solid, or combination of three solids, like one is on the base, second is on the top. Like this we are going to place a combination of solids. So here the first problem is very simple one, and it's a simple cube. On the cube there is a sphere is centrally placed. So you have to imagine a cube, okay, cube is a base. On that, say, so this is what a cube, okay, on the cube there is a sphere is placed. So this you have to draw it in the isometric. This is what the final. So first what you have to do is, first you have to draw the front view. If possible, you have to draw a front and top view of the combination of the solids. Like first it's a cube, okay, and on the cube there is a sphere is placed. So this is a front view of the combination of solids. And similarly the top view, yes, there is a square, okay, and centrally it placed a cube. So it's a top view and this is a front view. By using this top and front view, we are going to construct isometric view. Okay. And first I already explained, either you just draw it a normal dimension, and finally with the help of scaling you have to reduce. That's one method. Second method is directly convert the dimensions and draw it. Here normal 50 for the front and top view. If it is isometric, you have to use ISO 50. So ISO 50 means it is not exactly 50 mm, it is less than 50 mm. So 50 mm into 0.812 you have to multiply, so that it may give 40 something. So that is the dimension. Okay. So either you are constructing in a normal sheet or isometric sheet. In isometric sheet no need to convert, because already isometric sheet is with a isometric scale. If you are drawing in a unruled empty sheet, then you are using this isometric scale. Clear? Yes, I will show you. So first you have to construct a cube, then placed a sphere. So I told you have to follow a box method. For any drawing you have to use box method. But for the sphere, okay, say this is what the sphere means. Imagine a ball. It may be a small ball, or it may be a football or volleyball, whatever it may be. It is a ball. So it's having a 360 dimensions. So if you see that sphere in a top view, it look like a circle, same circle. If you see in the front view, it look like a same circle. If you look from the side, or if you look any angle, it will look like a same ball dimension. It won't change its dimension. Clear? But apart from sphere, if you take any other solids like cube, like cylinder, like slabs, okay, or any complicated profiles, if you take, it will change. In a front and top view it look at original positions, original dimensions, but it is in the isometric, it will change its dimension. Then we have to go with the ISO 50. So only we drawn, see here it's a ISO 50, because it changed the dimensions while seeing in the isometric. But for this sphere we take a normal dimension, because the ball or a sphere is, if you see from the top, front, side, whatever a position, if you see, it will look like a same 50 mm. It won't change its dimension, only for a sphere. Apart from sphere, rest of the solids are changes its dimension, so only we consider ISO. Okay, see here ISO is there, here there is no ISO. It's a normal dimension, sphere dimension is 50 mm. Clear? Yes. You have to use the box. Okay, first draw the line like this. It's a horizontal line because directly you are going to construct. So before that, you better draw it in the top and front view. Okay, so it's a square is there. So square of width 50 and height 50, and one more circle is there, and that circle dimension is 50. So this is what the a front and top view of the okay. So here first construct this. This is square. It's a cube. All dimensions are equal. First to draw a line 30°. That line length, we know that it's a first you construct in a normal dimension, then you convert to ISO. Similarly here a 50 and 150. Okay, then draw a parallel line with respect to this. Its length is 50, parallel, then closed. Similarly, it's a base. Cube means it's having a base as well as top. So we constructed base. Next, what you have to do is, so either you just construct an axis, okay. First find out the center for this, then the height is 50, okay, placed here. Next what you have to do is, we already constructed a bottom face, copy this, move option, like this you have to place, okay. See here, what you have to do is, we just constructed a base, then move the same base to the top by moving option. Clear? So now time to place the sphere. Why we have to reduce this 40.81 means because it is a ISO 50. A normal 50 mm is there, but when it is in isometric, it is become 40.8. Clear? That's why it is called as ISO 50 or 40.8. So we have to convert this to isometric, then go for construction of sphere. So sphere is there. Its length is 40.8. So this is its length. Here you are going to place the sphere. So that sphere of 50 mm placed here, and make this as visible. So like this you have to construct. Then later, if you want, you can remove this inside line. Yes, this is a final view of a cube or an sphere. It's a front view and this is an isometric view. You can cross verify its dimension is 40.8 mm or it is a ISO 50 mm. And this one is 50. Sphere is 50 mm. Whether it is in the isometric, it is also same 50, or it is in the normal front and top view, its dimension remains same 50 mm. It won't change. Sphere, only sphere won't change its dimension. Okay. So like this you have to construct. If you construct like this, you will get a full marks. This is of 30 mm and this of 30 mm. That's why it is called isometric projection. So in the isometric projection, you can able to see, okay, so it's a one view, you can able to see, this is another view, and this is an top view. So you can, in a single view, you can see a front, a side, and top view. That's why it is called isometric view. So this is another problem. Problem number 4. The following figure shows that here they given a top view. Okay, by using this top view, you have to construct this. So this is what you have to construct. Okay, and this is what they given. So the following figure shows that a top view, they given top view of a cylinder which is centrally mounted, means placed on a frustum of pentagonal pyramid. So frustum means it is not exactly pyramid. Okay, pyramid is cut at a certain height, then it is become a frustum. If it is didn't cut anywhere and it will reach the apex, then it is become a complete pyramid. If it is cut certain height, then it is become a frustum. Okay, so here frustum of pentagonal pyramid. So pentagonal pyramid is cut at a height. It will cut certain height. It is become frustum. And this pyramid of height 60 mm, and draw the isometric projection of the combined solid. Here there are two solids. First is first you have to decide which one is comes in the bottom or on the foundation. On that, which solid going to mount, that you have to decide. In the problem, they clearly given that a cylinder is centrally mounted, means on that frustum, on that pentagonal pyramid, frustum of pentagonal pyramid, we are going to mount the cylinder. So this is a combination of two solids that you have to write by using this view. The view is directly given. Clear? And also the dimensions of this cylinder and dimensions of this pentagon is also given, and height is 60 mm. Okay? Yes, we'll construct. Yes, take the same line. Okay. First you have to construct the pentagon, and you have to construct a box for that pentagon, because it is easy to construct. We already know that we are following the box method. So here pentagon, first pentagon is of 50 mm side, 50 mm side, okay, with edge left side, corner right side. So in that position you have to construct 50 mm, and the top pentagon is of 20 mm. Yes, construct first pentagon, it's of 50 mm. Then so before that, already either you can go with a manual method or the software method. I already explained how to construct pentagon. So 50 angle 0, 50 angle 72, a 50 angle 72 into 2, a 50 angle 72 into 3, and 50 either directly you can close, or you can give 50 into like this, you can construct. Once the construction is over, copy this and rotate. Exactly vertical, you have to rotate. Okay. Then you have to construct the box for this. Use the line. So like this, use your scale and pencil, you have to construct box. I name it this box as a 1, 2, 3 and 4, and you can call it as, this is A, this one is B, this is C, this is D and this is E. So, like this you have to construct. So, this dimension is 50, okay, and this dimension you should measure. So, 1, 2, 3, 4. So, first placed here, okay. So, we are going to rotate this, this is 30 degree, and here it is 150 degree, and this one is a 2, okay. So, 1 to 2, 2 to 3, 3 to 4, 4 to 1. So, there are points. So, 1 to 2, this is 1, this is 2, there is a point A, and 2 to 3 there is a point B, and 3 to 4 there is a point C, and 4 to 1 there are 2 points D and E that you have to construct. And this dimension that you have to measure from here to here, the dimension is and from here to here the dimension that you have to measure it, okay. So, 2 to 3 the dimension is 80.9, okay. So, cut the arc, use this, and the dimension is 80.9 and cut the arc. Similarly, from 2 to 1 is 76.94. Again you have to cut the arc and remove extra. Then use the line with parallel to this, okay. So, this dimension is a 76, we already know that, placed here, and finally join. So, like this you can construct the box, and you can call it as a 3 and 4, and this is 1. So, now it is time to place the points like A, B, C, D, E. So, take the same compass, and 1 to 2 or 2 to 1 there is a 1 point, okay. So, from here cut the arc of 47.55, that is a one method, okay. So, in your manual method what you have to do is you just take the compass and placed on 1 stretch up to A. That steel head is there, no, in compass, placed on 1, and that pencil head stretch up to A. Then placed it here 1 and cut the arc with the help of that pencil head, so that you will get a point A. So, this is point A, okay. Similarly, you just take the same compass, placed it on 2, placed it on 2, okay, and stretch up to B and placed here, okay, and cut the arc. Like this you have to cut the arc, so that you will get a point A, B. And once we already got the point A, so which is parallel to the point C, so that no need to again construct, you just draw a parallel. A parallel line that you have to draw. So, this line is parallel to this, like this you have to draw, and you can call it as this name as C. So, now we need a point like E and G. Again take the same compass, placed it 1 and stretch up to E and cut the arc, okay. So, that distance is, and cut the arc. Similarly, placed it on 4 and the same distance it is of, and cut the one more arc, and you can call it as this name is E and this is D. So like this we got all the points. Then first point A to point B to point C to D and finally D to E. Then close it. So this is what the manual way of constructing the pentagon. Once the pentagon is constructed, then make it a visible one. So like this you have to construct the pentagon. And after constructing the pentagon, you have to mark the center. We need a center for this pentagon. We already know that the pentagon center means so the pentagon center, or else you can go with the box center. Exactly middle, draw the line. Yes, this is what it gives the center, which is a center for pentagon as well as center for the box. So now the height is how much? The height is 60 mm. Okay. So draw vertical 60 mm line. Clear? Place the scale here and draw 60 mm height. So here again we have to construct one more pentagon. We have to construct one more pentagon. And you just copy this, okay, and move. You just move somewhere, because again no need to construct pentagon like the previous way. We already got the one pentagon and we scaled down and placed here, and use the scale, and this dimension is 50, okay, and we need 20 mm. So for that use the scale, and this is what the scaling, and here so 20 divided by 50. So that gives the a pentagon with reduced scale. And copy this, move option, placed exactly center, and move here and placed here. So like this you have to construct. So this is a 50 mm and this is a 20 mm. They are given in the problem. So 20 mm is a smaller top side of the pentagon and bottom side is 50 mm pentagon. Okay. Yes, we constructed 20 mm, 50 mm with the help of scaling option. We just scale down. No need to construct again. You just save the time. Okay. And once the construction is over, okay, now it's time to join all the edges like A. So this is A with respect to A you have to join, and this is a B, a C, you have to join C, okay, like this you have to join all the edges. Then remove the hidden edges. Just erased inside extra projections just to avoid the conflictions. Clear? So this completes the frustum of pyramid, pentagonal pyramid. Okay, the first one is over. So now the second thing is you have to place the cylinder. Okay, you have to place the cylinder exactly on the center. Clear? And you just placed exactly on the center of the pyramid, frustum of pyramid. Okay. So this cylinder dimension is it is of height is the length is 100, okay, and 50 mm. So it is of 50 mm. Okay. So this height is ISO 25 means that the width is 50, okay, diameter is 50. So it's a 50 mm cylinder with a 100 mm length. Yes. So here better you construct okay. So separately you construct, we already know that. So this is what a 50 mm. Okay, line. So 50 mm, sorry 25 mm, diameter is 50. Okay, place it and construct box for this. Okay, directly the box is also dimension of 50 because the, so if this is a say you just measure this dimension is also 50 box. Okay, that is why construct a box of 50. So use construct here. We need a front view, so that construct vertical 50 and from here it's a 50 of 30 degree, next 50, then join, and we already know that how to convert that circle into ellipse by using 4 center method. You take a line and from here to yes, see here. So from this center to draw middle of this line, and again from here middle of this line, again from here middle of this line, and again from here middle of this line. Draw a line, okay, from this corner to middle, from this corner to middle, like this, and you will get a 4 centers by using your compass. This is the first center, okay. From here to here you have to cut the arc, then second center this one, from here to here you have to cut the arc, and third center is from here to here you have to cut the arc, and final one from here to here you have to cut the arc. So like this you have to cut the arc like 4 arc, that will complete your ellipse. Okay, and from this center is over, and now we got the center point here. From this this length is 100 and this is of 150. Okay. So draw the line, horizontal line, because the length is 100 mm. So this line is length of 100 mm and it should be inclined to 150, because this line is parallel to this line. It should parallel to this line. That's why this angle is same 30, because it's isometric, and here also same, it is 30. Okay. So this line is also should be parallel to this line. That's why we constructed this line parallel to this line. So draw a 100 mm line, and then finally you just copy this and exactly on the center. Okay, move here. Then use the line, tangent like this, okay. So what you have to do is you just draw a line which is tangent to this, and here also same thing, like this. You have to draw the line, tangent line. So now exactly here what you have to do is you have to 25 mm, okay. Then move option exactly middle, okay, placed here. And remove some of the hidden lines which are merged inside the it's better to remove. Yes, like this you have to remove the some hidden edges. Yes, now it clears that a frustum of pentagonal pyramid, on that centrally a cylinder is placed. So like this you have to construct. So directly you can construct on the frustum of that pentagonal pyramid, or better you can construct a side then placed here. And after this select entire thing, then go to the scale option, and that scaling option is 0.816. Now placed here. See, so this gives the ISO. See, actually 50 mm is there, but ISO means it reduces. Okay, so like this you have to convert to isometric. So first construct as it is in the original dimensions, then convert it to isometric, and once this over, then delete this. Yes, this is what the a final view of a frustum of pentagonal pyramid at a height of 60 and centrally mounted a cylinder of 100 mm length, 50 mm diameter. Okay.